Okay, this is the third video in Unit 8, and this video I'm going to talk about ellipses. So the definition of ellipse, let's actually get this down here. So an ellipse is a collection of points in a plane, so points in a plane such that the sum of the distances from two fixed points, and those fixed points are called the foci, is constant. So a constant sum, and if you remember the activity we all did with the string, well, that constant sum is the length of the string, and that length of the string, so if I do F1 and F2 standing for my foci, and P is some point on the ellipse, it's always the case that F1P plus F2P, so the sum of the distances from those two foci is constant. And was it always equal to? Yes, it's equal to the length of the string, but we also discovered in class it's equal to 2a. And what the heck is 2a? Well, 2a is going to be the length of the major axes. So when you think of an ellipse, it has two axes of symmetry. So if we think of, this is an ellipse with a horizontal major axis. So it's got some center. And the major axis is the longer of the two axes. So these distances would be a. And the minor axis is length 2b, which each of these distances would be b. And if we're talking about an ellipse with a vertical major axis, the labeling is the same, except it's in the vertical direction is that major axis, and in the horizontal direction is that minor axis. And what also did we learn about the foci? Well, we also in class found that, so if these are the foci, and the distance from the center to the foci we indicate as c, we saw that the relationship between a, b, and c were a squared equals b squared plus c squared. And how do I remember it, that a squared is that one that's alone? Well, if I think of the ellipse, the further from the center is the endpoints of the major axis, so a squared is always the biggest. So a squared equals b squared plus c squared. Okay, so let's now do some more specifics in terms of an equation of ellipse. Well, foiled out, let's go back to this general form I talked about when we talked about circles. So if I've got this foiled out version, how do I get clued into the fact that it might be an ellipse? And of course you need to complete the square to be sure, but the good indication that it's an ellipse is that I have two different squared terms. So I should say two different variables that are squared. So this x squared and y squared, and the coefficients are different. Same sign though, and that's going to come into play, different signs when we talk about hyperbolas, but a and b should be different. If they're the same and the same sign, likely a circle, could be a point or no graph, but not going to be an ellipse. But if they're different but the same sign, it's a good indicator that it's going to be an ellipse. Okay, so after you complete the square, let's talk about the two forms of the ellipse, two equations of ellipse you could have. So if you have a horizontal major axis, so it is longer in the horizontal direction, then you're going to have the following equation once you complete the square: x minus h squared over a squared plus y minus k squared over b squared equals 1, where the center is hk, the length of the major axis we talked about is equal to 2a, the length of minor axis is going to be 2b, and of course that's going to help you draw the graph because you're going to go In this case, from the center, you'll go A in both x directions from the center, and you'll go B in both y directions from the center to create the endpoints of your ellipse. And in terms of, you need to find c squared is going to be a squared minus b squared. And once you find c, you can find the foci. Since x is the major axis, the foci are going to be in the x direction. So to find the foci, you're going to go from that center, you'll go plus or minus c, and the y-coordinate will still be the same. The foci always lie on that major axis. So how I know I have a horizontal major axis is the bigger number will be under the x squared once I complete the square. So for example, if I have something like this, plus y plus 1 squared, say, over 1 equals 1. So it's in this form here. This tells me because the bigger number is under the x is going to be the major direction in this ellipse. Another thing about the ellipse is eccentricity, and eccentricity is defined as c over a. And this really is telling you kind of how skinny, if it's a skinny type of, more ovally shaped type of ellipse, or if it's more kind of getting super close to a circle. If it were a circle, the eccentricity would be 0. So the closer eccentricity is going to be between 0 and 1. Notice because in an ellipse, A is always bigger than C, it's never going to be greater than 1. And so but the closer it is to 1, the more kind of skinny you could think of it, the more like a skinny oval versus looking more like a circular shape. So that's what the eccentricity tells you. All right, so that's the horizontal major axis. Now let's talk about, well, what if it's a vertical major axis? So super similar, and then we'll go through completing the square. So vertical major axis. The only difference in the equation is the smaller number is going to be under the x squared term when you put it in completed square form, or this form here. And in this case, the foci will be in the y direction, so it'll be hk plus or minus c. And sometimes if you're confused and are just asked to find, the various vertices and the foci, and you're not asked to sketch your graph, sometimes it's helpful just to sketch to make sure you're doing things properly. Okay, so let's do an example. I want to make sure, well, maybe I'll just make something up. All right, I'm going to go on to a new sheet. We'll see how this goes. I may have to backtrack if this doesn't work out pretty, but I'm going to try. Okay, so 4x squared, let's see. Let's do plus 2y squared minus, I want it to work out a little bit nice. Let's do minus 8x plus, let's do plus 8y, and give me a second here. I'm going to pause it so I can think of something. All right, let's just do minus 4. Okay, so we're going to so one clue that this, by the way, before I even start, say this was with a bunch of different equations and I was trying to figure out what I might have, what conic I might have. I have 2 different variables that are squared, and their coefficients they're both positive coefficients, and they're differing, and they differ. One's 4, one's 2. Then I'm thinking I likely have an ellipse here. Okay, so let's complete the square in x, and completing the square in y. And half that linear coefficient is squared, so plus 1 means I add plus 4. And you know what? I'm going to change this to a +4. Sorry about that. Let's change that to a +4 and make this a -4. Just want it to work out a little bit better. Okay, so half of 4 squared, half of 4 is 2, squared is 4, which means I've got to add 8 to the other side. So I've got 4x minus 1 squared plus 2y plus 2 squared equals 8. And remember, I want to get that 1 on the right. I definitely don't have a circle. These coefficients are different. So I want to get a 1 on the right side. So divide everything by 8. And I get x minus 1 squared plus y plus 2, x plus 1 squared over 2, sorry, plus y plus 2 squared over 4 equals 1. All right, definitely an ellipse then. And my a squared is 4, and my b squared is 2, meaning my a is 2, b is, and you could say plus or minus, and b is plus or minus root 2. And so the bigger number's under the y, so it will have a vertical major axis. So, and the center is at 1, 2. So I've got my center there. And again, the major axis is in the y direction. So to get the endpoints of the main major axis of my vertices, I'm going to go up and down 2. So those endpoints would be 1, 4 and 0, 4. And then the endpoints of the minor axis are going to go left and right, root 2, so about 1.4-ish. So, and the foci are in the in that y direction. So my foci are going to be same x coordinate 1, but then oh, wait a second here. Let me erase this. I'm doing this whole thing at 1, 2 instead of 1, -2. My bad. All right. Well, I'm sure people caught me before doing that. My apologies. Let's redo. Sorry about that. The 1, -2. Sorry. I should write it down. My center is 1, -2. Okay. And then, so I'm going to go 2 up and down in the, to get my vertices or the endpoints of my major axis. And then I'm going to go about 1.4 in each direction. And then my foci are going to be within in the y direction. So the x coordinate, it's the same as the center, and the y coordinate, I do -2, and then I've got to figure out what c is. C squared is going to be a squared minus b squared, so c squared is 2, or c is plus or minus root 2. So my foci are going to be -2 plus or minus root 2. And so those would be my foci in there. And what else do I want to find? Let's find the eccentricity. So the eccentricity will be c over a, so root 2 over 2. And that's about it for the ellipses. Again, my apologies for drawing that incorrectly at first. And so those are your ellipses. I actually like ellipses. I think of these 3 so far, the parabolas can be the most tricky. Okay, and that is it for that.